Hello, everyone. In this recording, we will be discussing an introduction about hypothesis testing. So before we start doing hypothesis testing, let's try to summarize what did we do in chapter, or what we did in chapter 7 and 8. And actually, it connects all of the chapters that we covered. So let's first look at the idea. The goal, the general goal, the overall goal is what? Is to get some information about populations. Basically, we would like to have informed decision about population's mean or population's proportion. These two proportions. These two parameters that we are focusing on. We have other parameters basically, but these are the main two parameters that we are focusing, the mean and the proportion. As we said before, we have so many examples. You would like, for example, to know something about the average prices of the houses in a certain specific state, let's say, or the proportion of people who passed SAT exam, or the proportion or the percentage of, let's say, sales that exceed certain number, etc. So all of these comes from population. But the problem that we have no clue. We have many problems here. We don't know these from the population. Also, we don't know how the population look like. So we don't know the distribution of the population. Is it something like this? Let me make it easier and use the curves. Is it something like this? Or is it something like that? Or is it something like this? Or is it something like this? We don't know. We don't know the distribution of the population. Where is the frequencies? The mean, where is it? We don't know anything about this. So what we were able to do is taking a sample, just single sample. This sample, we require this sample to be large enough. If you get a large sample, then we have a good information about something. What is the other information that, okay, what the new thing that we are knowing now? What are the things that we start knowing? A very nice idea that we know that the sampling distribution, again, this is kind of confusing sometimes. The sampling distribution is normal. Someone is going to tell me, what is the sampling distribution? Again, the sampling distribution is all samples taken from that population. Someone is going to tell me, yeah, but we have never taken all samples from. Yes, correct. This is correct. We will never have access to all samples from population. Correct. We have only access to at least one sample is enough. Why is this? Why one sample is enough, and why it's a good idea to know about the sampling distribution. This curve, this normal distribution, represent all samples taken from certain population. But our sample, by the way, has an average. So if you take, for example, 100 observation, and if you take the average of these, it's going to be X bar. So you will be having X bar from here. X bar, this is now the most important thing. X bar is going to be somewhere like, it's going to be either here, or it's going to be here, or it's going to be here, right? So it's going to be in one of these places, this one sample that we took. So then what? The other thing is, another nice information we got is, if the sample is large and we got the sampling distribution, we know something. We know that the middle value here is the mu, which is the population mean. And this is what we are looking for. This is what we have been looking for, the population mean. So what? We still don't know mu, correct? We don't know mu. We know X bar now. But from last chapter, we know the confidence interval. We know where is the mu between what value and what value based on the confidence interval. So this was chapter 8. So we can tell some information about the mu from having X bar. So that's why we had the confidence level, which is normally 90% or 95% or 99%. And we talked about this. What does it mean by confidence level? That if I take 100 samples, let's talk about this one. If you have 100 sample, so the mu is going to be between the two values in 99 of these samples. So the higher the confidence level is, the more accurate is going to be your estimation of the confidence interval for the population's mean. This is not enough, because now we will be doing something more, and we will have more information about the population mean. We will be doing something called hypothesis testing. What is the hypothesis testing? Is a statistical procedure. It used to do what? It used to make inferences and draw conclusions about a population based on the sample data that we got. And it involves formulating basically two competing hypotheses. So we have two competing hypotheses. The first one, we're going to call it null hypothesis. The second one, we're going to call it alternative hypothesis. Most of the book called the null hypothesis as H naught, and the alternative hypothesis is HA or H1. Okay. After formulating the two hypotheses, we are going to assess the evidence from the data to determine which one of these hypotheses is supported. What is the difference between the two hypotheses now? The null hypotheses always represent the assumption of no difference relationship. There's no difference, there's no relationship, there's no effect in the population. And it is always formulated as the default or status quo. So it takes always the status quo position. And as I said, it's always states there is no significant difference, or there's no effect between the groups. There is no relationship between the variables. This is the null hypothesis, is the default situation. Everything is the same. There is no difference. Examples. H naught can be the mean height of males equals the mean height of females, let's say. Right? There's no difference. Again, there's no difference. It's always involve the equality or the status quo scenario. Or it can be there's no difference. There's no difference in the test scores between two teaching methodologies. Okay, teaching methodologies or techniques. Or it can be, let's say, the mean income of the doctors is less than or equal. Actually, let's do this. It's greater than or equal. Look, certain number. Let's say $150,000. This is maybe the status quo. The opposite is going to be what? The opposite is going to be the alternative hypothesis. The alternative hypothesis is going to be what? The mean height of male is different from the mean height of female. Okay? Or there is a difference in test scores between two teaching methods. Or the mean or the average of the doctor's income is going to be less than 150. Someone said, no, it's less than. So we have to test this. We have to see this claim, right? So the goal, as I said, is to evaluate or assess the evidence from the sample data to determine whether it provides enough support to reject the null hypotheses. The goal is to see, do we have enough information? Do we have enough evidence to reject the null hypotheses in favor of the alternative hypotheses? And all of this is going to be based on statistical analysis. So we are going to do We are going to have 3 methods of doing this. And again, we'll be using Minitab for this. And last thing I would like to say is, the null hypothesis, we will be always assuming, this is important, again, this is an important statement now. We will be always assuming the each node is true. It's the default state of nature. So when you start your analysis and you're gonna formulate your each node, you're gonna say, assuming there's no difference, there's no relationship, right? It's going to be your status quo, okay? So you will be assuming the null hypothesis is true. Then you collect your data, and we're gonna conduct the statistical analysis to evaluate the evidence against it, okay? So we need to determine if the observed data provides sufficient evidence to reject the null hypothesis in favor of the alternative hypothesis or no. This is the goal of doing our chapter now.